Welcome to my YouTube channel T.NATH'S Physics class. Today I'll discuss few 3-mark question from CBSE class 12 physics exam 2020. Let's start. First question. In a single slit diffraction experiment, light of wavelength lambda illuminates the slit of width A and diffraction pattern is observed on a screen. Number A. Show the intensity distribution in the pattern with the angular position theta. Number B. How are the intensity and angular width of central maxima affected when number 1. Width of the slit is increased and number 2. Separation between slit and screen is increased. So it's a 3-mark question. Okay, so as per the first question, this is the intensity graph with respect to angle. Okay, in case of single slit. Second part. So we know that angular width of central maxima beta theta equal to 2 lambda by A, where A is the width of the slit and lambda is the wavelength. Again, we know that intensity is directly proportional to width of the slit A. Also, intensity is inversely proportional to separation between slit and screen. So these are the information you have to remember to solve this one. Okay. From equation 2, intensity is increases. Is it clear? Because intensity is directly proportional to width of the slit. Okay. So as per question, here width is increased, so intensity is increased. Now from equation 1, angular width is inversely proportional to width of the slit. So as you increase, the angular width will be decreased. From equation 3, as we know, intensity is inversely proportional to distance between slit and screen. So as you decrease the distance between slit and screen, then intensity will be increased. On the other hand, width of central maxima is independent of distance between slit and screen. So there is no change of width of angular width of central maxima. Okay. Next question. With the help of simple diagram, explain the working of a silicon solar cell. Give all 3 basic process involved. Draw it IV characteristics, that is current voltage characteristics. So this is the diagram, simple diagram. Okay, P stand for P and N, PN type junction diode here. So here light is incident. When the sunlight is incident on the P surface and enough sufficient to enter the junction, then this energy will break the covalent bond, due to which electrons and holes are created both sides of the junction, and these charge carriers constitute a small amount of current, and that current is called the minority current, and this current is directly proportional to intensity of incident light, and it is also depend upon the surface area of the junction while light is incident. So what are the processes involved in solar cell? There are 3 processes as here. So generation of electron hole pairs due to light incident on the junction, and separation of electron and holes due to the effect of electric field of the depletion zone, and third one, accumulation of electrons in n side and holes in p side develop a voltage. That voltage is called the photovoltage across the solar cell. So these are the three processes involved in solar cell. And they asked to draw the graph. This IV characteristics graph, this is the graph, and this IS is called the short circuit current. Okay. Next question, question number 30. A resistor R and an inductor L are connected in series to a source V equal V naught sin omega t. Find the peak value of voltage drop across R and across L. B. Question number B. Phase difference between applied voltage and current. Which of them is ahead? So they ask we have to find out the peak voltage for R and L. L means inductor, and then you have to find out the phase difference, and also you have to show which one is ahead. So here this is the circuit diagram when R and L are in series. So in across R, voltage drop will be VR equal to Ri, and in case of inductor, VL equal to XLI, where XL is the inductive reactance. In case of R, voltage and current has no phase difference, and in case of inductor, the voltage and current, voltage is ahead of current with phase difference of pi by 2, that is 90 degree. Okay. So first we have to find out the impedance of the circuit. So Z equal to root over R square plus XL square. Now we have to find out the peak current to find out the peak voltage. Okay, then peak current equal to peak voltage divided by impedance. And what is the value of impedance? That is root over R square plus XL square. Okay, now we have to find out the peak value of voltage drop across R. VR equal to I naught R. Now insert the value of I naught. This is V naught by root over R square plus XL square. And peak value of voltage drop across L, VL equal to I naught XL. Insert the value of I naught, that is V naught by root over R square plus XL square into XL. Okay, and this on the phasor diagram. Okay, so according to parallelogram law of vector addition, if two sides are represented by two vectors, then resultant is always along the diagonal, and this V is the resultant voltage. So from this diagram it is very much clear that resultant voltage and current has phase difference of phi, and voltage is ahead of current. Now the phase difference between V and I is tan phi equal to VL by VR, then VL equal to IXL, VR equal to IR, II cancel, then it becomes XL by R, then phi equal to tan inverse XL by R. So as I mentioned earlier that V is ahead of I. Okay, next question. Write the expression for the speed of light in material medium of relative permittivity epsilon r, relative magnetic permeability mu r. Write the wavelength range and name of electromagnetic waves which are used in radar system for aircraft navigation. And number 2, Earth satellites to observe the growth of globes. So it is a knowledge based question. Velocity of electromagnetic waves in metal medium is V equal to 1 by root over mu epsilon. Now mu equal to mu naught epsilon r into mu naught epsilon r. Then 1 by mu naught root over mu naught epsilon naught is c. So ultimately it will be V equal to c by mu r epsilon r. This is the expression of velocity of electromagnetic wave in metal medium, where c is the velocity of light. So in radar system, microwaves are used, and its wavelength range is 10 to the power minus 3 meter to 0.1 meter. To observe the growth of globes from satellite, we use infrared, and the range of infrared is 7 into 10 to the power minus 7 meter to 10 to the power minus 3 meter. So this much for today. So rest question I'll show in my next class. Thank you for watching my video. Stay safe and stay at home.